All right. Good afternoon, everybody. Thank you all for coming to this session, Establishing a Data Perimeter on AWS Feature in Vanguard. Here, you will learn how to establish organizational-wide guardrails to help prevent unintended access to your data. My name is Tatiana Itskevich. I'm a Senior Solutions Architect in AWS, and I'm here today presenting with Raj Sharma, Chief Security Architect at Vanguard. So data perimeter may mean different things for different organizations, but this concept and all AWS development behind it was primarily driven by organizations in regulated industries, such as financial services. Those organizations wanted to ensure that the security controls over the data that they were bringing into AWS were consistently guarded against unintended access. And this is why I'm really excited to co-present with Raj, who will be sharing Vanguard experience in implementing data perimeter controls as one of the pioneer influencers and adopters of this concept in AWS. But first, I would like to give you a brief overview of what is data perimeter, security risks it helps mitigate, as well as AWS tools and capabilities that you can use to establish data perimeter controls in your environment. And then Raj will walk you through Vanguard journey in implementing data perimeter controls with the key steps and decisions that they had to make along the way. We will cover a lot of material today. We will be looking at a lot of IAM policies. While we'll be going through that material, just keep in mind that you don't have to implement it all at once. The purpose of this session is just to give you a very holistic overview of the data perimeter framework so that you can make intelligent decisions along your own journey. So what is data perimeter? We are all very well familiar with the principle of least privilege, which is giving your users and applications only the necessary privileges for them to complete their task. This is simple in theory, but may get quite complex in practice with multiple developers creating and operating a variety of different applications in a dynamic nature. This is why in AWS, we prefer to look at least privilege as a journey, where you first give your developers a set of privileges to cover potential needs, and then you verify and refine those permissions as your workloads mature and you learn more about your environment. While you advance through that journey, though, you want to give your developers a certain level of freedom so that they can innovate and build fast on AWS, but do that in a secure manner, enforcing certain organization-wide rules, universal controls that shouldn't be subverted intentionally or unintentionally by anyone operating in individual accounts. And this is what data perimeter coarse-grained controls allow you to accomplish. So data perimeter is a set of preventative guardrails in your AWS environment that help ensure that only trusted identities can access only trusted resources and only from expected networks. And the guardrail is a very important aspect here because data perimeter doesn't grant any access. It rather enforces security invariants that your organization operates under, those organization ground rules. And those rules and definition of trusted and expected will vary based on your organization's security requirements and data access needs. But what data perimeter allows you to do is to draw a clear line between everything that you consider within the realm of the intended use of your environment and what is outside of it. So in its simplest definition, data perimeter allows you to establish a boundary around your corporate AWS accounts and everything within them, identities, resources, and networks, plus on-premises environment you are in full control of as well. Everything else, non-corporate AWS accounts, the rest of the internet is considered untrusted and shouldn't have access unless given that access by explicit exception. And you would start with defining these three terms by looking at what you own and in full control of. That being, trusted identities usually encompass IAM principles within your AWS corporate accounts, which are normally part of AWS organizations. Trusted resources would include resources within those accounts. Those are S3 buckets, databases, instances that store and process your data. And finally, expected networks normally include your on-premises corporate IP space and AWS networks, AWS VPCs. Those definitions, though, wouldn't be complete without considering scenarios where AWS services act on your behalf. In those cases, AWS services may be using their own principals to access your resources, or they may be using your principals to access your resources, but from their own networks. So you would normally extend the definition of trusted and expected to also include something that is under the control of AWS services. Considering those definitions and different data access patterns, we can define 6 distinct security objectives within the data perimeter framework. We divide them in 3 categories, 3 perimeter types. With the identity perimeter trying to reason about who is making the call, with an intent to make sure that only trusted identities can access your resources and your networks. Resource perimeter is trying to reason about what is being accessed, with an objective to ensure that only trusted resources can be accessed by your identities and from your networks. This is essentially to prevent developers on premises or applications in your VPCs from accessing data stores which are not approved by your company. And finally, network perimeter is trying to reason about where the request is coming from. Network perimeter controls help ensure that your users and applications credentials cannot be used from networks which are not managed by your company. This might be important for organizations that don't want their employees taking their corporate laptops to a coffee shop and accessing corporate resources, potentially bypassing other controls that may exist in the intended path. And you may have different reasons for that drive those security objectives. And Raj will walk you through what it is for Vanguard. But when it comes to implementing data perimeter, once your security objectives are outlined and well-defined based on your meaning of trusted identities, trusted resources, and expected networks, you can start achieving your security objectives by implementing IAM, Identity Access Management policies, at various constructs within AWS organizations. So data perimeter essentially is a set of IAM features and capabilities that allow you to build that boundary around your assets. And there are 3 policy types that you will be using to implement data perimeter controls. Service control policy is an organizational policy that allows you to establish the maximum permissions available to your users. You can apply an SCP in your organization at the root, an organizational unit, or an account level. Resource-based policies are policies that you can attach to resources directly to control access to those resources based on your application requirements. And finally, VPC endpoint policies are policies that you can attach to VPC endpoints to further restrict access that is allowed through those endpoints based on your security requirements. In the data perimeter framework, you will see that the correct policy type that you will be using to implement a specific security objective would depend on where you will be implementing the control, which resource you will be securing. For instance, with the identity perimeter, where we're trying to ensure that principal making a call is our trusted identity, there are 2 places where you can make that assertion: on your resources, using resource-based policies, and on your networks, using VPC endpoint policies. With the resource perimeter, you will be using SCP, and VPC endpoint policy to ensure that only trusted resources can be accessed by your identities and from your networks. And finally, with the network perimeter, you will be using an SCP to ensure that your corporate credentials can only be used from your networks, and you will be using resource-based policies to ensure that your resources can only be accessed from expected networks. So until now, we learned main definitions within the data perimeter framework. We also looked at various security objectives within the framework and different policy types that can be used to achieve those objectives in your environment. The question now is, how do you actually codify those definitions and security objectives in an IAM policy language? But before that, how many of you are worried about your developers accidentally granting access to someone outside of your organization, or even public access to your resources? Show of hands. All right, many of you, right? So this first objective within the identity perimeter helps mitigate this exact risk. But the obvious happy path here is your corporate credentials being used to access resources within your organization, right? Those are IAM roles or IAM users accessing resources such as S3 buckets and databases within your accounts. So all of this data access path that you see in this picture, from the data perimeter perspective, are considered valid data access patterns. Again, we are not looking at the least privilege here. You will still be applying IAM policies to grant fine-grained permissions for your applications. Here, we are looking at the access from the organizational boundary perspective. And from that perspective, the resource-based policies attached to your SQS queues, SNS topics, or S3 buckets wouldn't deny these data access patterns. What you want to deny, though, is use of non-corporate credentials to access your resources. Those could be identities in other AWS accounts or even unauthenticated access from somewhere in the internet. Now, remember I mentioned that we need to take into account AWS services acting on our behalf. So the first example here is when you configure AWS CloudTrail to continuously publish your account logs to one of your S3 buckets, CloudTrail uses service principal, cloudtrail.amazonaws.com, to make that call to Amazon S3 service. That service principal doesn't belong to your account. It actually belongs to CloudTrail service account. And you need to permit that access through your perimeter if you use that service. When it comes to codifying all of that in the resource-based policy, in order to differentiate between principals that belong to your organization and those that don't, you will be using principal org ID condition key that you can see on the bottom left side there, or its sister keys, principal org path and principal account. Principal org ID condition key specifically allows you to compare the identifier of the AWS organization to which calling principal belongs with what you define in the policy. And in order to permit the service principals through your perimeter, you will be using principal is AWS service condition key. This key is set to true when an AWS service makes a direct call to your resource using the service principal. Whether it's CloudTrail publishing logs to S3 or AWS config invoking your Lambda function for custom config rules. Now, how many of you are worried about your developers bringing their personal account credentials into your network, maybe by exporting them in an instance CLI, and trying to transfer data that resides in your corporate network to a personal S3 bucket or any other resource in personal account? Some of us, right? So when it comes to the use of your network, the intended data access pattern here is your corporate credentials being used from within your networks to access resources within your organization. Those could be applications running on EC2 instances, storing some data in your S3 buckets. So this is intended. What you want to prevent, though, is the presence of non-corporate credentials in your network because it represents a risk of potential data exfiltration. When you implement controls to prevent this type of data access pattern, you need to account for scenarios where AWS services access AWS-owned resources from within your network, not using your corporate credentials. So, for example, when using AWS System Manager patching capability, SSM agent running on your EC2 instances makes unauthenticated calls to AWS-owned S3 buckets to fetch patching baselines. And you would need to permit that type of access through your identity perimeter if you use that particular feature. So in order to codify those assertions in the VPC endpoint policy, right? We are protecting your network in this case. So we will be implementing VPC endpoint policy to ensure that only trusted identities can be used from your network. And similar to the previous security objective, you will be using principal org ID to differentiate between corporate and non-corporate credentials in your network. And in order to permit access to AWS-owned accounts, AWS-owned resources, you can just list the ARNs of those resources within your policies. So those are, for the most part, are publicly accessible resources, and their ARNs, Amazon resource names, are documented in relevant AWS services documentation. All right, moving to the resource perimeter. With this perimeter, we need to ensure that the corporate credentials within our accounts can be used to access resources that we own, right? For instance, AWS System Manager parameter store parameters, which reside in our accounts. What we want to prevent, though, is our corporate credentials being used to access parameters which are outside of our organization. Just keep in mind that in certain circumstances, you will need to grant access by your corporate credentials to AWS-owned resources. So, for instance, your users and applications may need access to EC2 AMIs, Amazon Machine Images, which are published as public SSM parameters. So you need to account for that kind of access pattern when implementing resource perimeter controls. And when you start building your service control policies and VPC endpoint policies to implement your resource perimeter, the primary key, condition key that you will be using is resource org ID. Resource org ID allows you to compare the identifier of the AWS organizations to which the requested resource belongs with the identifier that you specify in your policy. And again, in order to allow access to AWS-owned resources, you can just list those resource ARNs in your policy. And finally, the network perimeter is the perimeter that allows us to ensure that your identities and your resources can only be used from your expected networks, which is your corporate data centers and AWS VPCs, but not a coffee shop. Here, you see a direct access by your identities to your resources. And this is the access pattern that you would like to protect the most with the network perimeter, because humans here have access to credentials and can take them somewhere. In order to codify the definition of expected networks in an IAM policy, you will be using two primary condition keys, source IP and source VPC. Source IP is to specify allowed public IP addresses, and source VPC to specify IDs of the VPCs that belong to your organization. So when implementing network perimeter controls, you also have to account for, for AWS services acting on your behalf, accessing your resources from outside of your networks. One example is when an AWS service uses credentials of a principal making the original call to then make subsequent requests to other AWS services. For instance, you may have an application running in your VPC creating an Athena query. Athena then takes that application's credentials to access your S3 bucket for the data and return results to your application. That call from Athena to S3 comes from Athena service account network, not from your network. And in order to account for that service access pattern, as you can see on the bottom left side of the slide, you can use via AWS service condition key. Now, remember the CloudTrail example? When CloudTrail publishes logs to S3 using the service principal, that call also doesn't come from your network. It comes from CloudTrail service account network. And again, here you can use principal is AWS service condition key to account for that access pattern. There are also services that use service link role to access your resources from within their own networks. For instance, AWS IAM Access Analyzer uses an SLR called AWS Service Role for Access Analyzer to analyze resource-based policies and produce its findings. SLR is a special type of role that is linked to a specific service where that service controls and defines permissions associated with that role. SLRs have a reserved path in its ARN. So you see on the bottom left there that the SLR actually has this AWS-service-role prefix in its ARN, and you can use that to treat that role in a special way in your IAM policies. So these AWS service access patterns are actually safe to permit through your network perimeter because here you can rely on AWS responsibility for security of the cloud and its controls to secure credentials, your credentials, when they're used to act on your behalf. There is another identity type that can be used by an AWS service to act on your behalf, which is a service role. So service role is a role which is not an SLR that can be assumed by an AWS service to perform its job. That role is created in your account. It can be changed and deleted from within IAM, and that role also restricted by SCPs that apply to your accounts. So first example of a service using a service role is Amazon Comprehend using a service role to perform analysis jobs on documents stored in your S3 bucket. In this case, Comprehend service is in full control of the credentials that are generated by the service role, which means that users don't have any mechanism to obtain those credentials. And this essentially means that you can treat this role as an SLR and permit it through your network perimeter using either the IAM path that you use to manage those roles or a tag that you assign to your roles. There are, however, services that use a service role to perform certain operations on your behalf, as well as to make API calls from your code. For instance, AWS Glue uses a service role to create network interfaces for VPC deployed Glue jobs and publish logs to CloudWatch. It uses that same role to run Glue scripts. So since this role is used to run your code, users in this case potentially can obtain credentials which are generated using that service role. That means that you should treat that role similar to your human roles. And we have several mechanisms to kind of account for this access pattern in the data perimeter controls. You can use not action element of an IAM policy to exclude actions such as create network interface from your source IP, source VPC restriction. Also, as you can see on the bottom right of the slide, some services have service-specific keys that allow you to differentiate between sessions where an AWS service is in full control of your credentials and sessions where credentials are made available to your code. So you can treat those different types of session in a specific manner in your policies. But without going into much details here, because implementing network perimeter controls with service roles may become a bit challenging when you adopt a variety of different AWS services, you may decide to first target human roles with your network perimeter controls because they represent the highest risk, right? They can take credentials somewhere. And as a matter of fact, a lot of our customers took that approach, and Raj will talk you through how kind of Vanguard approached that. And then you can extend the coverage of your network perimeter guardrails to services such as EC2 and Glue, where credentials are actually available to your custom code. That way, you can kind of gradually enlarge the scope of your data perimeter guardrails. All right, putting it all together, this table summarizes all the concepts and capabilities that we discussed so far. Key point to take away here is that there are primary condition keys such as principal org ID, resource org ID, source IP, and source VPC that allow you to restrict access based on the organization and location your identities, resources, and networks belong to. And there are condition keys such as principal is AWS service and via AWS service that can be used to extend your perimeter to include AWS services acting on your behalf. Now, there are a lot of controls, but they are pretty independent from each other, which means that you don't have to implement them all at once. We've seen customers doing that in phases, kind of gradually enabling those guardrails in their environment based on their own risk-based approach to security. And now I will pass it over to Raj, who will talk to you about why data perimeter is important for Vanguard and how they approached implementing data perimeter controls in their environment.
Thanks, Tatiana. So, hi everyone. My name is Raj Sharma. I'm a cloud security architect at Vanguard. And just a little bit of background about Vanguard. Vanguard's one of the largest investment firms in the world. We have mutual funds, ETFs, advice offerings, as well as other related services. And our mission statement is to take a stand for the investor, treat them fairly, and give them the best chance of investment success. As far as the assets under management, Vanguard holds about $7 trillion under management. They're held in about 411 funds worldwide. And Vanguard was started operations back in 1975 with a single site in Pennsylvania, near Valley Forge, Pennsylvania, and has since expanded to 19 different global locations. We have over 18,000 employees that we call crew members, and we serve 30 million clients externally. So this is a fairly large enterprise from that standpoint. And we really need to protect our data, protect our shareholders. So why have a data perimeter? So we have the data perimeter to implement organization-wide permission guardrails. It really helps to protect that data within the account. We also want to improve our data loss prevention strategies and prevent that unintended or even malicious data transfers. And then also establish these organization-wide data perimeters for developers. So if we can create a framework that developers can work in, where they can work on this least privilege model, and they know that they're going to operate in a safe environment that gives them more flexibility to develop faster. Okay, so where do we start, right? So when you're thinking about a perimeter, most people think about a network perimeter. And the network perimeter could be, let's say, a firewall. And you're really talking about, hey, there's some principal out there that needs access to a resource, so we're going to create a firewall rule and let that traffic through. And that was basically our on-premise type of perimeter. Within AWS, we have this new concept called the data perimeter, which is a set of IAM authorization controls. And this encompasses things like the service control policy, the VPC endpoint policy, session policies, and the IAM permission boundary policies as well. The IAM permissions policy and the resource policy are what really help make up that least privilege model. So when you take that network perimeter control and you put it together with the IAM authorization controls, you have what we call as our effective perimeter, right? So you want to put these things together. You don't want to throw away your network controls. So these controls could be things like your endpoint agents on your endpoints, let's say your workstations and servers, network DLP, you screw up gateways, proxies, firewalls, things like that. There are, as Tatiana mentioned, there are some controls that are network-based controls that fall under the IAM authorization controls as well. So this becomes our effective perimeter. So as most people started with Amazon, you start with one account, right? That everyone has a single account that they start with. They may quickly go into the second account, but when you have a single account, the way that the IAM access control works with least privilege is you have an IAM permission policy and a resource policy. Either one of these can grant access within the same account, all right? So if a resource policy grants access to a principal, that principal will have access to the account. This type of interaction does not go through the data perimeter that we're talking about. Once you set up that second account, at this point, if you have a principal that needs access to a trusted resource, both sides, both the IAM permission policy as well as the resource policy, need to grant access in order for that to work. And that will flow through what we call as the data perimeter. The resource policy is something that is being added to various services, and it really allows that capability of the multi-account infrastructure that most people use today. In fact, if you go back and look at the APIs within AWS, you'll notice since 2015 to today, the number of services that have added resource policies to their offering has increased from maybe like 3 back in 2015. We're up to like 25, I think 26 now of services that have resource policies. So this is a really a great benefit when you have a multi-account infrastructure. However, it does introduce the risk of misconfiguration and unattended access. So what are some of the things that we can do to control that? We can have administrative controls. And when you look at administrative controls with sort of their ease of customization and strength and effectiveness, an administrative control is pretty easy to customize. You can tell someone, hey, go look for this. People are very good at reading code and figuring things out. But the strength and effectiveness, there's no way one person can look at hundreds of rules and try to evaluate them in a piece of code. You can also have detective controls. So as things are being deployed, you can use things like Lambda, CloudWatch, or even AWS config. These are things that a little bit more difficult to customize. You have to write a little bit of code, but they are more effective. And then finally, the preventative IAM control, which we're talking about here, which can be a little more difficult to customize. And that's why we make it sort of an overall data perimeter. But it is very effective, right? You'll get an instant access denied. There's nothing stopping that. So we use all these controls in unison. There's never just one thing or the other. So when we're looking at, let's say, the administrative control in our environment, this is really the code review process. So you have the developers, they issue a pull request. Some tech lead will review the pull request. The security engineer may review the pull request. If they both approve, the build happens. So once the build happens, we have Lambda functions that run in the environment. They look for misconfigurations. They go against an exception table. Maybe there's an exception for a certain type of, maybe a third-party access, trusted third party. And then if it finds anything that's out of line, it'll go and either scan the environment and then remediate it, or maybe alert the user depending on the type of severity of the vulnerability. So this offers the ability to break builds. It has continuous monitoring built in. So it is a very effective control, right? But what happens is the infrastructure has been deployed. So there's a time that there may be some risk out there. So some of those challenges I'm talking about, for administrative, the rule coverage is difficult to perform manually. And then for detective controls, you have to write code, right? Or you can also acquire, let's say, a third-party CSPM that has really good cloud infrastructure and entitlement managements. You can use AWS config, that's another thing, but if, depending on your infrastructure, you may have to customize the way config works. Although these are challenges, these are still being used, and they are effective controls and not to be overlooked. But what we want to talk about here is the preventative controls. So we want to set up that set of guardrails to ensure that you have access, that the access to the trusted resources is restricted to trusted identities from the expected networks. And so what I want to do is go through those 6 objectives that Tatiana talked about in the first half. So the first one here is that we want to make sure the trusted resources are denied access by untrusted principals. And really the simplest way to do this is through a resource policy. So you don't want this untrusted principal accessing your resource. The problem with this resource policy is that it's really more of a least privilege policy than a data perimeter. And if you have principals, let's say these principals here on the bottom are trying to access these buckets, you're going to wind up with sort of this mesh type of authorization model. It's difficult to manage. Also, if you have, let's say, an auditor that wants to come along and look at your S3 buckets, or some sort of third-party scanner, or like custom scanner that needs to scan your buckets, maybe Macy needs to go and scan them. In order to do that, now you've got to go and update all the resource policies in all these buckets, which then increases the size of the policy. And if you have hundreds of thousands of buckets, this is a difficult thing to do. So what we did is to move this up to a higher level is we took the roles and we created path-based IAM roles. So we moved let's say in this example, a developer, and moved it under a path called universal, as an example. So when you look at the resource policy, the original resource policy looks something like this, where you had all your user-based roles, right? And then you had some of the machine roles listed here. And if you needed to add a new role, you'd have to go and update this policy to add the role. Like we said, the data perimeter is really designed not to grant access. So you notice this is a deny statement, okay? This is not actually granting access. This is setting the perimeter of what is allowed inside the resource policy. So what we did is we took that path-based role, and now this is what our resource policy looks like. So we have a single resource policy with a like condition, and now any of these roles will match that, okay? We also have the principal service name here. So we have AWS principals that can also access this bucket, for example. Now, the thing is we have to be very careful about what roles wind up in this path, right? Because all of a sudden these roles can have sort of wide access to all your resources. So we have to add a second SCP on top of that. So at the entire organization level, there's an SCP that blocks access to any of the IAM functions, except for the few people that are in the security account. So what we've done is created kind of like a data perimeter using resource policies and path-based roles. Okay, all controlled by one central organization. We never actually granted access to anybody, we just set what the boundary was. Okay, so trusted principals allowed access from the expected networks. So this would be implemented from principal conditions within the VPC endpoint policies. So here you have a trusted principal, and then in this example, we're going to deny access to an untrusted principal. An untrusted principal may be somebody brings their credentials from home and tries to run them within your account. So to understand how VPC endpoints work, for those not familiar, if you have a principal within your VPC, it's going to have access to a network interface with a route table to an endpoint. That endpoint is going to have a policy. And in this example, this is an S3 endpoint for the S3 service itself. So what we put in the policy here is we actually used the principal org ID condition. So what this policy is doing, it has an allow statement, allow star. And the thing to realize here is that, again, this is not granting access. A VPC endpoint policy is just setting the boundaries. So it's just saying what is possible. The only thing possible here is actions as long as the principal org ID matches this ID, this example. The second statement under here is for trusted third parties. So if you have a third-party service that needs to talk back, you have to allow that as an exception as well. So these would be account numbers for that third party, and they can go and access. So these are two statements that we put in place here. There could also be services. So any AWS service that's running in your environment that needs access to an S3 bucket, you can create another exception here for principal is AWS service. So as far as trusted resources allowed from expected network. So in this example, we have just any principal out there. And we want to make sure that, that only the trusted resource is allowed from my network. Okay. So here the resource perimeter is going to be put in the VPC endpoint again. And I'm sorry, this was, there's a lot of policies here. Right. Yeah, only trusted resources allowed by network. So here the resource org path is the new IAM condition. And what it means is that the principals that are in my network, right, inside my VPC, are going through that VPC endpoint and can only access resources that belong to my organization path. Okay? So the two paths are listed here, and also we've added the existing principal org ID. So basically my principals can only access my resources from my network, right? That's how they're doing it. And then the second one here is for the third party access. So here you have the third party is let's say 1999. So that principal is allowed access to resources in the 199 account and also in my account, which is let's say 2888. So this way a third party can interact with my account as well as their own account. The other resources that we are going to allow access to are some of the Amazon resources. So these are, let's say, packages for updating Linux AMIs or Windows AMIs. So you want to make sure that you call out those exceptions as well, because these buckets do not exist within your account. They exist in a separate Amazon account. So this one is my principals denied access to untrusted resources. So here I have a principal here, and I want to make sure that they can only access my resource, regardless of what network they're in. So you would do this through a service control policy. And again, resource org path is your friend here. This is the new condition. This greatly simplifies your IAM policies. So now you can just specify what paths again. And just like we had with the VPC endpoint, we can list our trusted parties. And then also if there's AWS services, maybe there's service principals they need access, actually that are being called via your, through a AWS service. So this is your service using your credentials on your behalf that can call these things. This is another example for an STS, right? So like I said, there's many services out there that have resource policies or can be used across accounts. So this is just another example using STS. And here, these are my principals denied access from an unexpected network. So this is like that coffee shop example that was talked about earlier. Here we have my trusted principal. So whether they're coming from an expected network or unexpected network, we want them to be only come from the expected network. Now, one thing that we had to do here is we implemented this in two ways. We actually used the boundary policy instead of the service control policy, but you can use either one, just depends on how your use case is set up and how your architecture is set up. And what's interesting about this use case is that as people were working from home, we had this funny work from home scenario where the user's working from home and their home IP address is 203.0.113.4. And they're coming over the internet, over a VPN, into our corporate data center. And from here, we have, let's say, proxy servers that egress the internet traffic back out into Amazon, and that proxy server address, public IP address, is, let's say, 198.51.134. All right? What was happening was that VPN connection may get dropped for whatever reason. Maybe it timed out, something happened with the VPN concentrator, something, right? It timed out. Now, all of a sudden, that work from home user on that same laptop is accessing Amazon, but now from 203.0.113.4. This is where our security operations team started getting alerts, right? This will look like impossible travel, right? One day, 1 second they're coming from the data center, the next second they're coming from 80 miles away. So what we did is to limit the STS tokens generated by AWS to only the Vanguard network, is that we used the permission boundary policy and assigned it to the user-based roles. And here we use the source IP restriction to restrict it to just that IP address. The second thing that we had to do is, once we put that in, right, we started getting failures. People were complaining, hey, I'm getting access denied, what's going on? And the scenario was this. Let's say they were using Athena, and Athena was using an S3 bucket. So in this scenario, we had to add another condition that's to allow the via AWS service. So this is the scenario where an AWS service uses your credentials on your behalf to talk to another AWS service. We then did the same thing with principals within the VPC. In the VPC endpoint, instead of a source IP address, we did it with a VPC endpoint address. A VPC ID. So really that boundary policy created this effect of, yes, you can get through the proxy server, you can get through approved VPC endpoints, but not from your home network or an unapproved VPC. So as we're going through this journey, we want to bubble this up to a larger set of roles. So we want to put this up into the service control policy. So this is what a service control policy could look like as we put it up. How many people have put up a service control policy and then had like stuff just fail, right? Anybody, right? Yeah, see some heads nodding, right? So the other condition that we did is we added this one extra condition on the principal ARN because we wanted to focus it on those roles that were user-based roles, let's say, or a set of roles. So we didn't apply it to the entire account at once. This is kind of how we were rolling out the SCP. Okay, so now trusted resource is denied access from an unexpected network. So in this scenario, you would actually use a resource policy on an S3 bucket with a list of source IP addresses. The problem with this is that we have almost 100,000 buckets, let's say, and every time an IP address changed, we'd have to go back and update all the resource policies. So this was difficult to scale. So we actually did this through a combination of two other techniques that I talked about earlier. The first one was the trusted principals that are denied access from an unexpected network using that SCP or boundary policy. And the second one was the trusted resources denied by untrusted principals, just on that resource policy, that path-based resource policy. So the two of them together actually create that control in a scalable way. One thing that we did find with the network-based controls, which was interesting, was if you're accessing a resource from a VPC that's in a different region than what the VPC is in. So in this example, we have a compute instance inside of US East 1, and it's going to access another resource in East 1. That request will go through a VPC endpoint where the the policies and the permissions of that VPC endpoint will actually take effect. What we found is that if you're trying to access a resource from East 1 in US West 2, since VPC endpoints are regional, it'll actually go out the internet path, the egress path, and then it'll bypass those permission checks. So to solve this problem, what we have is on the right-hand side is a networking account with VPCs in 2 regions, East 1 and West 2. These two VPCs, these two are actually peered together using Transit Gateway. And then using a private hosted zone, we're able to actually route the traffic from East 1 through the Transit Gateway in the networking account to West 2, where the endpoint there would then take over that. And there's documentation on Amazon's website on how to set up this architecture, this cross-region VPC architecture. So as we're putting these controls in place, I think one thing to understand is we have to be very careful when we put these data perimeter controls in, because they affect a lot of people. So what we've done is created, let's say, a CloudTrail to CloudWatch setup, so we can query CloudTrail events using insights. I mean, you could use a SIEM tool, a third-party SIEM tool. You could use Athena against CloudTrail, right? We just happen to use this one for testing purposes. So now we're sending CloudTrail over to CloudWatch to look at insights. And the reason we did that was we wanted to do some impact analysis first. So this is an insight query just to make sure, hey, let me look in the past so many days, so many months, whatever. Who's accessing buckets that are outside my accounts, right? I want to make sure that I have a good inventory of those things. So when I build the policy, I don't break anybody. Also, I want to make sure that nobody's doing anything funny or sending stuff back to their personal accounts or sending stuff to an attacker account. So this is a good way to go and check for that. And then once you have that list, you can go and vet the list and build your policy. The second thing to do is, like, once you put the policy in place, all right, as soon as you put it in place, keep watching the insights, because you may get a spike of access denied, right? As soon as you get that access denied, you have to go back out that change, right? And then go investigate why you got these access denied, right? So in this example here, we put an SCP in place, and we instantly got 600 access denieds, right? Just popped up out of an account. So immediately took that SCP out. The access denied errors went back down. We then investigated, found out we had missed an account number. We put the account number in. We vetted the account number, made sure it was a valid third party, and then kept going. So really, in summary, those are the controls. Those are the 6 objectives, and how we implemented them, and sort of the journey that we've been on to make sure that we have this preventative and detective and administrative guardrails that help ensure that trusted resources are restricted to just the trusted identities from the expected networks. And I think in conclusion, I mean, this is a really big topic, right? There's a lot to this, but start somewhere, right? Start with maybe user-based roles, since they're the most dangerous. People have the access keys, the STS tokens. They're easy to walk away. So definitely start with the user-based roles and just start building your policies, and apply for a few services at a time. The examples I showed here were all around S3. Look at your service listings, see which ones are the most critical. Maybe KMS is the next one, right? Maybe STS is the next one. It's just sort of like critical base services you want to start to tackle. So build a list of services and start hitting them one at a time. Make sure your conditions align in the multiple policies, right? You want to make sure that your VPC policy and your SCPs and your resource policy, your IAM, they all line up, because if one of those is off, you're going to get an access denied, and you're going to spend a lot of time trying to figure out which policy it was that caused the access denied. So, one thing to watch out for is make sure that those conditions line up. Learn how AWS uses principles on your behalf. You'll run into a lot of edge cases where you're going to access denied, you're not sure why, and you're going to find out that there's some AWS service that uses your credentials in a new way that you didn't think of. So look out for those types of access denied errors. And to keep the policy size and limits in mind, right? I mean, there is a limit to the size of the SCP, there's a limit to the resource policies, there's a limit to boundary policies, both in character and number. So really like plan out how you're gonna do this least privilege, this data perimeter model. Of course, I mean, test the non-prod, right? Monitor for those errors, look for, that's always a good thing, right? Don't just put it out in the production environment. And then also, most importantly, communicate with your end users, right? Because in our world, we have thousands of developers, and if you don't tell anybody that you're changing an SCP and then people start getting access denied, they're gonna spend a lot of time in their own IAM policy trying to figure out what's wrong, right? Before they call you. So you don't wanna have that time waste. The second thing is, maybe they get an access denied, but you didn't do anything, so they call you anyway. So if you don't have that communication, sort of that schedule of what's happening when, you can run into some problems with the developer community. Okay. And with that, thank you for attending our session.